So today we're going to review logarithmic functions. We learned about them in Algebra 2, and they are back again. So the first thing let's talk about. Last couple days you've looked at exponential functions. Well, logs are the inverse of exponentials. That's probably a good note to write down. And it's right here for you. So they undo each other. Now, this is not a math thing. This is purely a Miss Guidry thing, but I call it a little swooshy, like the Nike swoosh, but a little swooshy because it's cuter. To go from exponential form to log form or vice versa, you do a swoosh. So you always find your base. So in this case, my base right here is 2, and you swoosh towards the equal sign and around. So it's like follow the leader. So I was in exponential form, so now I'm going to log form. And so my base was 2, so log base 2. The next thing you touched was 8 equals 3. Same thing works on this side. My base is 2, so I'm going to swoosh you like this. So I touch the 2 first. Your base always stays the same. The next thing you went past was the 3 equals 8. I'm going to skip a line. It works on the next line also, but I'm just going to skip a line so you can see. Similarly here, log base 12 of 12 equals 1. And if I swooshy, 12 to the first equals 12. So they undo each other. Exponentials is what we've been playing with. Logs are going to undo exponentials. So now let's go to the bottom of this, or the middle of this page. Let's do a couple examples. So I have either exponential or log form, and I want to write the other form. So we're going to start at the base, which is 3, and swooshy around the equal sign. So log base 3 of 81 equals 4. Let's try the next one. So my base down here is 7. So 7 to the first power equals 7. My next one, my base is 14. So 14 to the 0th power is 1. Anything to the 0th power is 1. And then down here, start at the 1/2 and swoosh you like this. So log base 1/2 of 32 equals -5. So if I were to write the property in general, let's say I have a to the x equals b. So I make my swoosh. You start at the base, go like this. That's the same thing as saying log base a of b equals x. So hopefully that jogs your memory a little bit. So now let's use this swooshing and converting to evaluate some log and exponential functions at the bottom of this page without using our calculator. So at the bottom of this page, it says, to help you find the value of log base b of y, ask yourself, to what power of b gives you y? So then they give you an example. So I have log base 4 of 64. And so what they're saying is equals x. So if I were to convert this, 4 to some power x equals 64. Well, x has to equal 3 because 4 times 4 times 4, 3 times equals 64. So let's keep using that idea. So the first one says log of 5 of 0.2 or 2/10 equals x. We don't know what it equals. So I'm going to convert 5 to some power equals 0.2. I'm going to rewrite this for you. 5 to some power equals 0.2 is the same thing as 2/10, which is the same thing as 1/5. So I'm going to rewrite this as 1/5. So my x needs to equal a -1 because I need to send the 5 down to the denominator, but I don't want to change its value. I want it to stay 5. Well, if you raise 5 to a -1, it sends the 5 down to the denominator. Next one says log base 1/5 of 125 equals, we don't know. So we're going to convert 1/5 to some power x equals 125. Well, first of all, I hope you can tell me that x needs to be negative because I need to pull the 5 up from the denominator to the numerator. And then you need to ask yourself, 5 to what power equals 125? Well, 5 times 5 times 5, so 5 to the third. So I need my x to be a -3. A negative to bring the 5 up to the top, and then the 5 3 times to make 125. Now this next one's a little bit tricky. So if I convert this, 36 to some power equals 6. Now you can sit here and think of powers, or you can say, how is 36 oops, hang on, let me try that again. Related to 6? Well, the square root of 36 is 6. And if I want to write square root as a power, it's the 1/2 power. So I need to do x equals 1/2, because a square root is equal to a power of 1/2, and a cubed root is equal to a power of 1/3. It's always the power over whatever root you want to take. Well, I want 36 to be the first power, but I want to take the square root, so I put a 2 there. Okay, let's go to the next page and do some more special log stuff. Okay, so now let's make sure we have something straight about logarithms. So when we write logs, it's log base A of B. Log base A of B. Well, a lot of times in math, we have a very special A value. So for the common log, your A, which is your base, equals 10. Oops, 10. So we write log base 10 of B. And because we use this so often in math, we write this just log B. So when there's no base written, that means it was 10. Also, we have another number we use a lot for this A value down here. That's when our A, which is our base, equals E, which we know is 2.71, blah, 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 blah. So we write that one as log base E of whatever B. Well, we write this so oftenly in math that we call this ln of B. So when you see ln, that means your base was or is, however you want to look at it, is E. Okay, so now we're going to do a couple problems, and these require you to use your calculator. So a couple of problems to do. We have log of 8, ln of 0.3. We have log of 0.85, and we have ln of 22. Okay, so to do these, if you look right here by the one, you see where it says ln and log. That's what we're going to use to do these. So for the first one, it said log 8, so I'm going to press my control and then my log button, and I don't need to put anything for the base because the base is 10. You can just leave it blank, log of 8, and press enter. And there you get your answer. I'll go back and write this down in 1 second. I'm going to do another one while I have the calculator here. This one I'm going to press ln. This time when you do ln, it doesn't ask you what the base is because they know it's E. And the last one, you'll notice now, if you look right there, because we didn't put a base, we just put log, the calculator knew that it was base 10. ln of 0.3 is that. So let me pause this video real quick. Move it off to the side. And let's write these down really quick. So my first one, 3 decimal places, 0.903. The next one was negative 1.204. Type the next one in. And you get negative 0.071. And type the last one in. 1. Okay, so let's talk about inverse properties. So logs and exponentials are inverses, which mean they undo each other. And if you remember back to properties of logarithms, if you plug one function, not logarithms, sorry, properties of inverses, if you plug one function into another and they are inverses, you should get x. For example, if I have log base b of something, and that something I'm going to plug in is an exponential b to the x, I get log base b of b to the x. Well, we don't know what this equals question mark. So if I do that swoosh thing that I always do, b to the question mark equals b to the x. Well, we just proved that this thing doesn't equal question mark. This equals x, which thus proves that these are inverses because they undid each other and yielded me an answer of x. So we're going to use this property to solve. The key to make this happen is that the two bases, the exponential and the log, have to be the same. So for example, let's look at this one. So I have 10 raised to the log base, well, it says log of 4. That's the same thing as 10 log base 10 of 4. Because this base for my exponential and the log base are the same, these will undo each other, which means we are just left with what was right here, which is our 4. So our answer is 4. Log base 5 of 25 to the x. Well, let's rewrite this. Log base 5. I'm going to rewrite 25 with a base 5, so they match. And right here, when you have a power raised to a power, you multiply. So this equals log base 5 of 5 to the 2x. Because my bases are the same, these will undo each other, leaving me with just this, which is my 2x as my answer. So just a quick couple properties. Log base a of 1 has to equal 0. That's because anything with a 0, the power is always 1. Log base a of a has to equal 1 because a to the first equals a. And log base a of x equals log base a of y. Since the logs and the bases are the same, then that implies that x has to equal y. So now we're going to move on to graphing.